Hey guys, so in this lecture video, we will be learning how to balance chemical equations. Now, so we know that balancing chemical equation is a very basic technique that all chemistry students need to be able to do. And the reason why it is so important for us to be able to balance chemical equation is due to the law of conservation, right? So the amount of substances that you have at the beginning and the amount of substances that you have to the end have to be the same. And so if we were to start with 3 atoms of something on the reactant side, we have to end up with 3 of those atoms on the product side because they can't magically just disappear. So here is a chemical reaction that we may have seen in the other lecture video already. And perhaps some of you were thinking earlier, it's like, hey, that equation doesn't seem to be correctly balanced. Then if that's what you saw, then you are right, because I'm saving this equation right here so we can learn how to balance it now. First, we need to be able to determine if a chemical reaction is balanced or not. And how that is done is by following simply counting the amount of atoms on the reactant side and the product side. So here is a chemical reaction we have seen already. Sodium reacting with water to produce hydrogen gas and sodium hydroxide. In this case right here, we're going to ignore this heat right here because heat is not a substance, so we can ignore that. And if we were to now count up to all of this atom right here on both the reactants and the product sides, this is what we will see. We will have 1 sodium, right? And we have 2 hydrogen, and we have 1 oxygen. These are the amount of each of these atoms that we have on the reactant side. And now when we count them again on the product side, we now see there's still 1 sodium right here. And now we have 3 hydrogen. The reason why we have 3 hydrogen is as follows. There are 2 hydrogen over here plus 1 over here. So now there are 3 hydrogen. And there's still only 1 oxygen. So now when we compare the reactant and the product side, the amount of sodium remains the same. The amount of oxygen remains the same. However, the amount of hydrogen are not the same. We have 2 hydrogen on the reactant side. And now we have 3 hydrogens on the product side. So you can see the hydrogen atoms are not balanced. And so that tells us now we need to be able to go ahead and balance this equation. And how we would be able to balance the equation is by adding coefficient, by basically adjusting the stoichiometric coefficient. This stoichiometric coefficient right here are basically value, this x, y, z, whatever value they may be, and we also call them the multiplication factor that we would add in front of each of the reactant or product to show the relative amount in a chemical equation. When we add this value right here, x, y, and z, in front of each of these substances right here, it does not change the identity of the substances, but all it tells us is now we have more of one or less of the other. But again, the chemical formula or the chemical identity of the substances do not change. And so this x, y, and z or w or whatever they may be, we call this the multiplication factors or the stoichiometric coefficients. And if we were to add x in front of a substance, here in this case x in front of A, whatever x may be, if x equal to 1, then now the amount of sodium will then be multiplied by 1. Versus if x equal to 2, then now the amount of sodium will then be multiplied by 2. So that's how it goes. And if we were to now add y in front of water, depending on what y will be, if y equal to 1, then now that does not change the amount of hydrogen and oxygen that we have in here. But if y is now equal to 2, we will now have 4 hydrogen and 2 oxygen. Does that make sense? So that's how they go. And similarly for the product side. And so now, when it comes down to balancing equation, there are certain guidelines to help us easily balance the chemical equation. And so by following these guidelines right here, it becomes very easy for us to figure out what we need to do to balance chemical equation. And here are the guidelines. First, start balancing the element that occur in only 1 compound on each side of the chemical equation. So look for the element that exists in only 1 chemical substance on both the reactant and the product side. And that is something that we go to balance first. And if there's more than one of 6 elements, then balance the metal before the non-metal. And we'll go over an example in a little bit to make sure this guideline makes sense. Well, let's actually go over it right now. So here in this case right here, start balancing element that occur in only one compound. So here in this case right here, we see that oxygen exists in only one compound on the reactant side. It only exists in water. It does not exist in sodium. So the water exists in only one substance on the reactant side. And water exists in only one substance on the product side as well. So therefore, water will be fitted as the element to be balanced first if the oxygen is not already balanced. Now, hydrogen would not be fitted into this definition right here because hydrogen exists in one compound here on the reactant side. However, it exists in 2 compounds on the product side. So therefore, it exists in multiple substances on the product side. And that is why we will not be balancing the hydrogen first. And the second guidelines, balance 3 elements last. So that will be the types of element to balance last. 3 elements are basically substances that exist by themselves, and in the chemical formula, there's only one type of element in them. For an example, H2, O2, all of this diatomic element right here would then be classified as 3 elements. And in addition to them, we also have metal. So for example, iron, gold, sodium, whatever that would be. That would be called a 3 element. And again, a 3 element is a substance in which there only one type of element in its chemical formula. And if we were to go over this example right here in this equation, we'll then see that sodium exists as a 3 element. So therefore, it will be an element that we will balance last. And similarly, hydrogen is also a 3 element as well because it exists as a 3 element here on the product side. So this tells us that sodium and hydrogens are the elements that we will balance last. And the third guidelines, use fraction as coefficient if necessary to balance your chemical equation. Yes, sometimes we have to use a fraction to be able to make the amount of the atoms of a particular atom on both the reactant side and the product side to be the same. But if we were to use any of the fraction at the coefficient, it would be more ideal for us to actually reduce them to whole number. And how we will be able to do that is we can multiply everything by the denominator. And that's how we can clear the fraction coefficient to change them into now whole number. And again, we'll see an example of that in a little bit. And then lastly, always double check to make sure that to the end, everything is correctly balanced. And if we were to go back at this equation right here, this equation right here would be correctly balanced by putting a 2 in front of the sodium, a 2 in front of water, and a 2 in front of sodium hydroxide. So now this chemical equation is correctly balanced. And why? And let's count the atom to make sure that the amount are the same. If we were to have 2 in front of sodium on the reactant side, we have 2 sodium. If we were to put 2 in front of water, then now again, make sure you distribute this 2 to the 2 hydrogen in here. So then that will then give us 4 hydrogen. And again, do not forget to distribute this 2 right here to the oxygen as well. So this now gives us 2 oxygen. So those are the amount of sodium, hydrogen, and oxygen we have on the reactant side. Let's now check them on the product side. So if we were to go over here, again, take this 2 and distribute them. This is why that we call this the multiplication factor. So 1 sodium here multiplied by 2 equal to 2 sodium. And now we will have 2 oxygen. So in this case, again, 2 oxygen. And now this will then give us 2 hydrogen. Plus the 2 hydrogen over here, that then give us 4 hydrogen. So if we now compare both the reactant and the product side, the amount of each of this atom right here are the same thing. So therefore, this equation is now correctly balanced. Let's now try a few of this practice problem right here to make sure we are getting and we know how to do this. So in the first reaction, here is a statement. So we want you to write the balance equation based on these statements that are provided. Ammonia reacts with oxygen gas to produce nitrogen gas and water. So now let's substitute each of their name by the chemical formula first. In this case, ammonia, the chemical ammonia is NH3. And ammonia is actually a gas at room temperature. So we know that it is a gas, and that's why that we will put in the parenthesis G. And again, we would be putting them in if we know them. And now oxygen gas. So here in this case right here, we are being told oxygen is a gas. And yes, oxygen is a gas at room temperature. And the chemical formula of oxygen is O2. Now, it is not O1 because O1 cannot exist by itself. But the most basic form of oxygen is O2 in order for it to exist by itself. And now, by writing the chemical arrow, and now everything being produced are then the products, and we're going to be writing them on the right side of this reaction arrow. Nitrogen gas is an N2. It is a diatomic element. And now water is H2O. And water at room temperature, it is a liquid. So therefore, parenthesis L. So again, we are writing the physical states of these substances right here at room temperature. Unless we mention some other very extreme condition where the physical property may be different, then we have to write the other physical property. But here in this case right here, we know that these are the chemical substances for this substance at room temperature. So there you have it. That is the chemical equation for this reaction based on this reaction description right here. And now let's see if this is correctly balanced. And now let's count them. So we see here there will be 3 hydrogen on the reactant side, and now there's only two hydrogen on the product side. So now we know that the hydrogen is not balanced. And the oxygen is not balanced as well. We have 2 oxygen here, and we have only 1 oxygen on the product side. And the amount of nitrogen are not balanced either. So in this example right here, there's nothing that is balanced. So let's balance them. So which element should we balance first? And if we were to reflect back to our guideline number 1, it's a balanced element that exists in only 1 compound on both the reactant and the product side, and balance free element last. So identify that element and identify our free element. So here in this case right here, we then see that oxygen is a free element, right? So therefore, we will not be balanced oxygen first. Nitrogen would be a free element as well. So therefore, we are not going to balance the nitrogen first either. But the element for us to balance first here in this case right here, well, oxygen is also a free element as well. So here in this case right here, the only substance that does not exist a free element would then be the hydrogen. So we have to balance the hydrogen first. And now on the left side, we have 3 hydrogen. On the product side, we have 2. So we have 2 and 3. How do we make them the same? Then the answer, we bring them to the common denominator of 6. So the common denominator of 2 and 3 would then be 6. So bring both sides to 6. And we will be able to bring the amount of hydrogen on the reactant side to 6 by multiplying this by 2, by putting the coefficient 2 in front of the ammonia. And now putting the coefficient 3 in front of the water. So now we are bringing the amount of hydrogen on both sides to 6, which would make them balanced. And whenever we put a coefficient in front of a substance, try to now balance the element that is also being affected by that coefficient. So here in this case, when we put 2 here, we are changing the amount of hydrogen, but we also change the amount of nitrogen as well. And now we have 2 nitrogen. So now we have 2 nitrogen on the reactant side. See if our nitrogen is now balanced on the product side, or if we need to do anything to it. And here in this case, we have 2 nitrogen as well. So that means our nitrogen is now balanced. So we move on to the next one. Earlier, we also put this coefficient 3 in front of water to balance our hydrogen. That will affect our oxygen and will give us 3 oxygen on the reactant side. So on the products, we have 3 oxygen. On the reactant, now we have only 2 oxygen, and there's no oxygen anywhere else on the reactant side. So therefore, we have to somehow make this 2 oxygen right here becomes 3 to make sure the oxygen is balanced. And how will we be able to change 2 to 3? Then we can either multiply that by a half, but normally we do not use a half. However, we'll be using 3 over 2, a fraction. 3 over 2 multiplied by 2 then equal to 3. So in this case right here, we are using a fractions to balance our equation. And there we have it. This equation should now be balanced. But again, anytime that we use fractions to balance an equation, to the end, we want to clear up this fraction right here by multiply everything by the denominator on that fraction. Here in this case right here, we see that the fraction here it have a 3/2, or the denominator equal to 2. So therefore, we need to multiply everything by 2. The whole point of multiplying by 2 is that when we take 2 multiply by 2 here, it will then equal to 3. So we are able to convert this fraction right here into a whole number. But if we were to multiply this amount of oxygen by 2, we have to multiply everything else by this same factor. So that way, their ratio and the amount will not be changed, and they remain to be balanced. So make sure we now distribute this 2 right here, or this is where we get that 2 from, to every substances in this chemical equation. That would then give us 4 ammonia. And now 2 multiplied by 2 equal to 3 O2. And now there's 1 here. If there's nothing here, that means there is 1. 1 multiplied by 2 equal to 2. So now 2 nitrogen. And 3 multiplied by 2, distribute this 3 to this 2 to water. That then now give us 6 water. Now you would only distribute this to the coefficient, but not the subscript in the chemical formula. Because if we were to change the subscripts on the chemical formula, that will now change the identity of the substance. So we're not balancing chemical equation anymore, but we are changing the identity of the substance, and that's not good. So only distribute this to the coefficient. Okay. And now, let's now double check one more time to make sure everything is correctly balanced. On the reactant side, we will have 4 nitrogen, and we will now have 12 hydrogen, and we have 6 oxygen, right? And now on the product side, we have 4 nitrogen, and we now have so 6 times 2 equal to 12 hydrogen, and now 1 times 6 equal to 6 oxygen. So those would be the amount of each of this atom on the reactant and the product side, and they are the same thing. So there we have it. This equation is now correctly balanced. Let's now try another example. Example number 2. So iron 2 iodines react with chlorine to produce iron 3 chloride and iodine gas. So let's give this problem a try before we go over the answer together. Now, so balancing equation is such a good exercise to practice because we are not only just learning a new topic, but we are also going back to help us remember naming as well. We have learned nomenclature before already, and this is a great chance for us to go back and apply that here in this new topic. Now, here's something right here. Here is a very good tip to keep in mind. If you get stuck on balancing an equation for so long, let's say it took you 15 minutes or 30 minutes, and you couldn't balance a chemical equation, then if that were to happen, then please go back to double check your chemical formula. Because if you do not have the correct chemical formula of the substances, you will not be able to balance the chemical equation. So again, if you can't balance the chemical equation, go back and double check your chemical formula. Okay, so here in this case, let's now go over this one together. So iron 2 iodine. Iron 2 iodine is basically FeI2. And now, since this is an ionic compound, all ionic compounds at room temperature are solid. So therefore, now we know this is solid, and we put that in. react with chlorine gas. Chlorine, so chlorine is a gas at room temperature, and the chemical formula is Cl2. And now produce an Fe3 iron 3 chloride. Iron 3 chloride is FeCl3. And this again is a solid because it is an ionic compound. And now iodine gas, I2, and it is a gas. Iodine can also be a solid as well. It exists both as a solid and a gas at room temperature. So that is our chemical equation. And now let's check to make sure this chemical equation right here is balanced. And here in this case, it's quite easy for us to see that this chemical equation right here is not balanced. And the reason why is we have 2 chlorine here and we have 3 chlorine over here already. And we have, and the iodine seem to be balanced, but then the chlorine is not balanced. And the iron here seem to be balanced as well. But in this case right here, we then see that our amount of chlorine is not balanced. So we have to do something about it. Now, ideally speaking, because chlorine does exist as a free element, so it wouldn't be something that we would balance first. But in this case right here, all the substances are balanced except for the chlorine. So therefore, we now have to go and balance it. And so we have 2 chlorine here and we have 3 chlorine here on this side. Anytime we have 2 and 3, then to make them equal, bring them to 6. By multiplying everything by bring them to 6, by multiply this 2 right here by 3, and multiply this side that is with 3 by 2. So that's how we make them equal. And again, whenever that we put a coefficient in front of each substance, go back and balance the element that is being affected by this coefficient that we just put down. Here in this case, this will now give us the help us correctly balance the chlorine, and now give it 2 iron. And now change them up iron. So now we have 2 iron on the product side. On our reactant side, there's only 1 iron. So that tells us now we have to put 2 in front of this to make sure our iron will be the same. And now that will give a 2 iron on the reactant side. And when we put a 2 right here, this is now affecting our iodine. And now we have 4 iodine on the reactant side. And on the product side, we have only 2. So therefore, we need to bring this to 4 by putting a 2 right there. And there you go. And everything else would remain to be balanced. And again, let's double check one more time. So in this case right here, we have 2 iron, and we have 4 iodine, and we have 6 chlorine. So those are the amount of atoms that we have on the reactant side. On the product side, we have 2 iron, and we have 6 chlorine, and we have 4 iodine. So the amount seem to be the same. So now this chemical equation is correctly balanced. Okay, so please try this other problem right here on your own.